Welcome. I'm Dr. Dave Turner. I am the application scientist for Beocat, the supercomputer or cluster computer at Kansas State University. Our group also manages or helps to manage BeoShock, the cluster computer at Wichita State University. This is an introduction to the Linux operating system, which is a variation of Unix. This is also going to cover writing shell scripts in Bash under Linux. You should be able to download a 3-page PDF that's here on the right. That is the quick reference that I constructed. Basically, I'm going to teach from this, but expand on all these things. So this is a good cheat sheet to print out and make notes on as a starting place if you'd like. A lot of this material is covered at this link, which is the HPC or High Performance Computing Carpentry HPC Shell workshop. This is a half-day workshop that's from a group called Software Carpentry, and people can contribute lessons to that. They're usually half-day or full day. They might be on something like this Intro to Linux, or it could be on a programming language like Python, or even scientific package, one particular to bioinformatics or something else, for example. But we're going to use as a resource this one called Introduction to Using the Shell in a High-Performance Computing Context. The first two sections of this are why use a cluster and connecting to a remote HPC system. This has already been covered in a separate video. One is Intro to Beocat on the K-State side, and then one is Intro to BeoShock on the Wichita State University side. So I'm going to skip over this and basically be covering the material in sections or chapters 3 through 6. If you look at the times here, they spend maybe 2.5 hours going over this, and I'll go through it much faster. Software carpentry tends to teach things fairly slowly and have lots of examples that you can work through. So if you want more than what I present, feel free to go through this and work through some of the examples on your own. I'll be teaching from the quick reference, but then I'll be doing the examples on the Beocat cluster computer, and I'm logged over into this on Helios, one of the head nodes. So that's running Linux there, and so that'll be where I'm showing you how to do all this stuff. It would be, all this stuff would work exactly the same on BeoShock as well. I'm in fact logged into one of the head nodes there, which is head node 2. So to start with, Linux is an operating system, just the same as Microsoft Windows or OS X on a Macintosh system. OS X on a Mac system has at its core Linux, so you can open up a terminal on a Mac and do these same things there. There'd only be very minor differences because it's a slightly different flavor of Linux. On Windows, you're doing strictly a graphical approach, but you can pop open a terminal window with like PuTTY and SSH in to a Linux system. Or we also recommend MobaXterm as a way of opening a terminal window, but it also helps to sync up files on your between the Windows side and the Linux side. So it's kind of a dual purpose application that's helpful in that environment. Okay, let's get started with discovering your environment. Linux commands tend to be short and usually abbreviated. That's good in that they're easy to type. It does mean it's a little bit more of a learning process. PWD, for example, is print working directory. So if we do that on Helios here on Beocat, you can see that I'm in the test directory. My home directory is /homes/ and then my username is Dave Turner. I am in a test directory, which is a subdirectory of that. So if we start in my home directory, homes Dave Turner is that the name of the base directory. If we want to find other information out, like what host I'm on, well, actually, I'm using that in my prompt already. So I have customized my prompt so that it always displays the host name that I'm currently logged into. I also have it up here on my title bar. So it's actually there, as well as the directory I'm working from is there also. So if I do a host name here, that prints out ICR Helios. If I CD to my test directory, you can see up here, it changed in the title bar. I'm still on Helios, but now it's giving the whole directory path. Some people like to customize their prompt here so that it contains both the host name and the path. But then as you go deeper into subdirectories, you have less of a screen to work with when you're typing. So I don't like doing that. I like popping it up here. This is one of the nice things about Linux is that you can customize your environment. Every command is really a program in itself with flags to customize and other things. And you can customize your environment like your prompt here and then your title bar. Okay, let's start with listing files and directories. The simplest thing to do is list. That's a list simple, and that lists all the directories that I have in my home directory, /homes/Dave Turner. The ones in blue, it's coloring these automatically. The ones in blue are directories. The other ones look to be, okay, sorry, we're in the test directory. So let me go to my base directory and do an ls. So again, all the ones in blue are other directories, and you can see the test directory over here. There are some things that are listed as executables, and that's what's colorized there. And then there's some that are not colorized. You can actually program it up so that you can customize what types of things you want colorized and how, but that goes beyond what we're going to do here. So you can modify most every command with parameters. And here's an example. We're going to modify ls over here with -L to give us a longer list. -A will give all files, including hidden files. Hidden files are ones that start with a dot. It's sometimes useful to have them that don't show up unless you're absolutely looking for them. And then the -H is human readable. So let's try some of those out. ls -L for a long list puts each entry into its own line. And it gives more information. This first section is the permissions. The D means it's a directory. And then these RWA X is read, write, execute for different groups. So it's telling me that me as a user is the first group of three. I have the ability to read, write, or execute in that directory. So that means execute means I can go to that subdirectory. People in my group have the right to read and execute, but not write to it. So I don't want them to be able to write onto my home directory. And for this one, since I'm an administrator here, I want anyone to be able to read and execute stuff I put in the apps directory, because I install software that other people need to use. And so this is the first process to share that directory. So then it puts my username, my group. This is the actual amount of bytes that are in that directory. And then the last time it was modified was May 5th. So if you look at the number of bytes, you'd have to count that up to figure out exactly how much it is. We don't want to do that, so I'm going to put another modifier here to make it human readable. Now, the only thing that changed is this part. Now it says 53 G for 53 gigabytes. So that means there's 53 gigabytes of data in my apps directory. A lot of these others are much smaller. This is 2.4 megabytes. So that's what that modifier does. Now we're going to add the -A and see how that changes things. Now you start seeing some of these dot files, and there are different config files and things like that. It's good to keep them hidden. They're often stuff that an application will put there. So it's not something you really need to be able to see most of the time. So that's why it gets prefaced with a dot so that it can stay hidden. But with the -A flag to ls, you can still take a look at it. Now, ls has a lot of options. If you want to know what some of those are, you can do an ls --help. And it'll give you a list of some of the more common ones. This is an abbreviated list. And here we see the -A that we used. You could also use a --all instead. So often there's a shorter version, -A, but a longer one that's prefaced by a --. So there's just a lot of different choices here, and that's something that eventually you'll learn with some commands like ls that's very common. You'll learn which ones you want to include on a regular basis in that. This is, again, fairly abbreviated. I just paged through it. If you want the full documentations, you do a man of ls, short for manual. And again, this will give you a more complete description of everything, as well as examples on how to use it. So you can get information just from the command line on how to use it with the --help, or by looking at the manual page. So a couple other things to note. Linux is case sensitive. So if you type ls as capital letters, it'll say, I don't know what that is, because it is case sensitive. It knows what ls lowercase is. This is one of the nice things also about Linux, is that if you're not sure if something will work or not, just go ahead and try it out. You in general won't hurt anything right up until we get started talking about removing files. If you remove a file, well, that's a pretty permanent thing. Beocat does get backed up as long as you keep your directory under 1 terabyte, but that's harder to get stuff off of a backup. So, but other than that, you really can't do much harm. So go ahead and try things. Spaces mean separation between the command and the arguments. So again, ls minus L minus A minus H, we separated all those with spaces. But what if you wanted to separate them with lots of spaces? That's just fine. It did the same exact thing. One space versus lots of spaces, it didn't matter as long as there's something in between there. If you did ls minus L minus A minus H, it doesn't know what that is because it thinks all those things are lumped together. Now, you can actually lump things together this way. And again, that did the same as if you separated them into 3 arguments. So that is one thing that you can do that's nice, is grouping the single letter parameters like that together. And I give an example, I give that example on the quick reference there. What if you wanted to try something like putting tabs in there? Okay, I start putting tabs in there and it doesn't work. Tab in some environments when you're editing things is a set of spaces, but not in this case. Tab has a different meaning, and so it doesn't work to put a tab in there and separate with spaces. Okay, so let's move on to creating and removing directories. So I'm on my base directory again. If I want to make a directory, I use the mkdir for make directory. Okay, let me back up and show you one more thing. One thing you can do that allows you to customize your system is you can do an alias command, and I do list that on the cheat sheet there. It's very common to use want to use the -L when you do an ls to get one line for each directory or file. And so very commonly people do an alias of ll to ls-l. And then that's the same thing as if you typed ls-l. If you want to get out of that, you just do that. And then I'm going to show you what happens when I do ll now. Okay, when I do ll, it's very different from doing an ls-l. When I do ll, this is colorized different. The D is colorized as blue because I'm colorizing all the directories over here in blue. Read is the R for read. I don't know if you can tell, but it's in red. The W is in orange and the X is in red, and so forth. And I also have it human readable here. And I took out some of the information about the group because I didn't want that. Now, why does my LL work differently from what all of you do if you do that alias or you do an ls-l? It's because I actually wrote a program up. It's a Perl program, Perl script, to do LL. I've been working in Linux or Unix, I'll say more broadly, for over 3 decades. So over time, I wanted to customize my LL and some other commands. So I wrote up this script to colorize things exactly how I wanted, and I use that all the time. So that is, again, one of the nice things about Linux is you can customize it however you want. In this case, I replaced the built-in ls-l functionality with a code that I wrote up in the Perl language. Okay, let's get back to the directories. So with my script, if I do an LL of TE, that'll give me only the ones that start with TE. So you can see test directory is there. That's showing that nothing is inside. So we've done a make directory of test underscore dir. The reason I put underscore there is because, again, spaces in Linux are used to separate arguments. So you in general don't want to use them in file names or directory names. If you use them in a file name or directory name, you have to protect them with a backslash. So it's just common to replace, if you want spaces in there, to replace them with an underscore instead, like test underscore directory. Um, if we tried to do I'm doing an up arrow to get back through some of these commands. So uh, make directory of test directory. If we tried to do that again, it would say it couldn't because the file already exists. So one thing that's common with make dir is to put a -p there. This will make the entire path to that directory if you had a path, but it also means that it won't cause an error if it's already there. It just didn't do anything more. If we want to remove the directory, it might be a little hard to read on the cheat sheet there, but it's an RM for remove, RMDIR. And now if we look at the T's, I have a test directory, but there is no test underscore dir. So if we start over again and do a make dir test dir, now if we want to move to that, we do a CD. CD is change directory. So if you're in a graphical interface, all you'd have to do is double click on a folder. We actually manually have to say CD to test underscore dir. Now, if we use our PWD to print working directory, it shows that yes, we're in the test underscore dir on my home directory. There are different ways of moving around. One is with absolute paths and one is with relative paths. So the PWD shows the absolute path there. So if I was in a different directory, like my bin directory, I can always go that's an absolute path because it starts with slash. Slash is the root directory. So slash homes is where everyone's home directories are. And so this gives me an absolute path clear to that test directory. And so I moved from an arbitrary directory to test underscore dir that way. You can also use a tilde. Tilde is shorthand for your home directory. So again, if we go back to my bin directory, if I do, this is also going to move me to the test underscore dir because tilde is short for slash home slash Dave Turner. That is still an absolute path, though, since it's not relative to where we are. If you want to go back to your home directory, you just type CD and that always puts you back in your home directory. So if I want to go to my bin directory, again, we're on bin. Now, if we want to deal with relative paths, a relative path would be something like dot dot means go back one level. So if I want to go back one level, now I'm on my home directory /test dir. This will also get me there, but it's done by doing it using a relative method. So I know these things can be kind of confusing to start with, but the CD is how you navigate through your directory tree, and you can do many levels this way. I'll show you a few tricks as well. If you know part of the name that you want to go to, you can use file name completion by hitting a tab. So I knew there was a BUP directory, short for backup. So I typed BU and I hit the tab completion, and that completed that for me. Now, if I hit it a couple more times, it tells me what's in there. And I see an old directory. It's got a slash at the end, so I can tell that's a directory. So if I do an O and hit a tab, that'll put me in there, and then I can uh, go again. Now, this is not going to be a directory. I know what's in there, but that would get me all the way there using tab completion. If I wanted to go down 2 levels, this would get me out of the old directory and out of the BUP directory, so I should be in the bin directory. And so you can navigate around there. And again, using the tab completion is a very good way of kind of shortcutting. It also makes sure you're not making any typos. If you make a typo, then it won't be able to complete it because there's no file or directory of that name. So it's a good habit to get into to use that shortcut. Okay, let's talk about creating a file. The easiest way to create an empty file is with the touch command. So I'm going to create an empty file called file.txt. And so that's what's there. You don't have to name a text file txt. It's kind of a common thing in Linux, but you can name it whatever you want. There is that flexibility. Certain files are named with certain ends, like files programmed in the C language are usually end with .c, for example. And computer languages have different conventions for what the ending is. And with text files, I could have just named it file if I wanted to, but that's pretty generic. If I want to move that file around, I can make directory dir2, move file dot, and I'm going to hit my tab to do file completion to di, and I'm going to do file completion. So the MV is to move. So I just moved that file to dir2. What do I have left? Let's see what's in dir2. Now it's there, or I can do a cd to dir2 and see what's there. If I want, I can also copy file.txt to file2. And again, I don't have to name it with the .txt. There I have 2 files. Both of them are empty, but that's using the copy command, CP. If I want to copy and retain all this information here, like the creation date, here you can see that I created file.txt at 6:36 and I copied it at 6:38. If I want to copy that and retain the information, I have to do minus RP, or at least the minus P will protect all that information. Now, if you look, file 3 has the same modification date as the original. So I've protected all the information about when it was created and things like that. Then again, here's the dangerous one, the remove command, RM. So RM file 3 will remove file 3 and that only. So if we do that and look, and now it's gone. So we are in directory 2. I'm going to go down one directory into the test directory. I'm going to make sure where I'm at, and we're going to do something even more dangerous here. First of all, I'm going to try to remove dir2, and it's going to tell me it can't because that's a directory. If I try to do a remove dir2, it's going to tell me it can't because it's not empty. So you can remove it by RM for remove, force, and recursive dir2. The force means it's going to forcibly do this. The recursive means it's going to remove dir2 and everything inside of it. And here's where some of the danger begins. You certainly wouldn't want to do this on any directory where you had things inside it that you wanted to keep. So again, be very careful with the remove command, especially when you do the -FR. It is common to use a remove -FR. You might just, when you type it, pause and make sure that's actually what you want to do. I will re-emphasize that later on when we start talking about using wildcards here in a few minutes. Okay, editing files. There's lots of ways to edit files. If you're on a Windows system and are more comfortable editing things there, you can certainly use MOBA Xterm. And then you edit it on the Windows side and you sync that up with the Linux side. And likewise, if you run things on the Linux side and get output, then you can sync it up and have it on your Windows side so that you can look at any output files. So that's a good way of doing it if you're on a Linux system to start with, or if you're on a Mac and are communicating with, for example, Beocat, a separate Linux system, then editing things on your laptop or desktop and pushing them over with an S copy every time can get somewhat tedious. So however you look at it, if you're going to work in Linux for any length of time, it's good to learn to edit things on the Linux side. Nano is a very simplistic editor. I'm not really going to go over it because it's really only used to demonstrate in demonstrations like this. It's not really useful because it's so rudimentary. The next one down is VI, which is also known as Vim. This is on every Linux system. It's my favorite because it's been on every Linux or Unix system since Unix came out decades ago. So I've been using it for over 3 decades, and it does have a larger learning curve because everything is an abbreviated command. Once you get used to it, it is very fast. I move along and edit files very quickly. It is entirely with the keyboard. It is not mouse, so you're not constantly going between the keyboard and mouse. But again, there is a big learning curve to it. So I did point you towards a link there that has a good tutorial on how to use VI if you want to go that route. VI can be customized as well. So I customized VI to colorize things the way I wanted in a bash shell script, for example. And you have colorizations for different computer languages that help point out the commands and separate them for variables and things like that. Getting around, again, you're just going to have to decide whether you want to go this route of learning to use VI or not. Okay, so there are different ways of downloading and uncompressing files, and I'm going to go over some of these kind of quickly rather than really showing examples. If you're given a file that's on the web, you can use wget or curl -O to download those. Not all Linux systems will support both, but one or the other should be present. And those top two lines on the quick reference show how to use those. A lot of stuff in Linux comes tarred up and compressed. That's a directory that has been compressed. Tar is to archive, a tape archive. So the naming convention is kind of old school. And then GZ is the compression, gzip compression. So if you get something like this, where it's bash lesson.tar.gz, for example, this is all the bash lessons that came with that HPC carpentry, HPC shell bash lesson. Once you download them, you have to untar them and uncompress them. Tar can do all this in one step, -XV. I think there should be a Z in there, F. And then you give it the name of the then you give it the name that you're going to uncompress as well as untar. If you're just going to do it, if it just has a .gz, then you want to do a gunzip or gunzip. To compress things, you do a gzip. There are other methods as well. .z, capital Z endings use compress and uncompress. .zip use zip and unzip. So a lot of these are dependent on how the original was compressed, and different operating systems use different standards. But Linux can deal with any of those with these commands. So I'll just leave those up to you to be aware of if you encounter any compressed files. And it'd be good if you actually practice on this, downloading one of those and uncompressing. Okay, so displaying the file contents. The easiest way is to use cat. Cat is short for concatenate. It just means that you're going to print out the whole thing. That means if it's 10 megabytes long, it's going to print it to the screen and you're going to see things scroll to your screen for several minutes as it prints that all to standard out or to the screen. The other commands here, more and less, are probably more common because they have pagers in there. Let me see if I can find a good lengthy one here. So let's use more here. And you can see that it started and put one full page out and then it stopped. So it's much nicer in that it will allow you to page. Now, if you hit a return, it'll do one line at a time. If you hit a space, it'll do one more page. And it only had a little bit of a page less. So that's more is a good one. Less came after that and has more options, but would do the same. It would do the same for this, but there's more options as far as uh, actually stepping through and doing some other things. So those will allow you to go through uh, different files and handle larger files. The next set of commands are very heavily used as well. If you want to just look at the first few lines or last few lines of a file, you can use head and tail. So for example, no, I use a shortcut. So if I use -3, that'll give me the first 3 lines. And if I do a tail, -3, that'll give me the last 3 lines. So that's a common way of just looking at part of a file as well. If you just want to get some idea of what's in the file, you can just look at the head of each file, for example. Other commands are things like WC for word count. Word count -L. Well, the -L will give us the number of lines. So there's 76 lines in there. If I take that out, it'll give me the number of lines, the number of words, and the number of characters in the file. So if I just wanted one of those, I would put a -L for line, a -W for word, and a -C for characters. And again, I know those because those are the 3 common ones I use. But we can always use our -help and see the -C counts the number of characters or bytes. And then this is lines, and this is words. Okay, now we get the fun stuff of using wildcards. Wildcards are used to match kind of anything or certain subgroups of anything. The wildcard asterisk is the most powerful because that matches anything. So if I want to just list, for example, the if I do an ls-l, that lists everything. ls-l, SB star would list everything that starts with SB and finishes with anything, because asterisk will match anything. And so that's only a subset. If I wanted to do SB and then anything, but only the ones that end in T. So you see all those start with SB and end in T. So the asterisk is a wild card that matches anything uh, in between those things that you specify. The next wild card is a question mark. A question mark only matches a single character. So if I did an ls minus L of S question mark, that would get everything S whatever, but only one character, which doesn't work in this case uh, since there is nothing. So if I had an SB.1 and an SB.2, and did the same thing. So I'm using another shortcut. I'm pushing the up arrow to get the last command. Up arrow again gets the one before that. That's another shortcut. So now I'm doing ls minus L of SB dot, and then my question mark. So that actually gets three things, SB.1, SB.2, and then I already had a file there, SB.R, that was up here. So I'm going to go ahead and clean my directory up there. So you can have other wildcards as well, like ls minus L, SB dot, and then inside square brackets, we can put either individual things like A, or we can put ranges. Like we can also put R through W. Now that's just going to do a single letter. So we put an asterisk. So this should get us every SB dot that starts with A and then or starts with anything R through W and finishes with anything because we put the asterisk there. So here's some SB.A's. And then R through W includes this one here and everything up to SB.wait. So you can see that you can construct some very powerful inputs to commands using wildcards. So these are just some other examples. Okay, let's go on to grep. So grep is a very powerful command for looking through a file and printing. It prints out only lines that have the pattern that you give it. So this is grepping for the word ACT5 with A capitalized in all the files that start with DMEL-ALL and finish with anything. So this would look through multiple things because of this asterisk in the file name, but it would search and print out only the one line. So let's construct one of those here. These SB files are all SBatch files that I use to submit jobs to Slurm. So if I want to grep for a given word in there, let's look at the time that I asked for. And we're going to do sb.start. This is going to look at all my SBatch files, so all files that start with sb dot. And it's going to only print out the lines that have the word time in it. And here you can see in sb.array, my time I was requesting is 1 hour. sb.awk, my time request is 10 hours. Again, here's 24 hours and so forth. So this is a very powerful way of looking through lots of files for a given string of text and printing it out to the screen. So here we're constructing a lot of things together. We're doing multiple things. We're looking through files and looking through multiple files for the same text string. Okay, let's talk about redirecting output. If we want to just dump something to the screen in Bash, we do an echo of hello, echo hello world. And I'm putting that in quotes because there's a space in there. A space will keep those words together. So if we want, I'm going to go back to my test directory and it's empty. So I'm going to do my echo and now I'm going to put it in a file. I'm creating the file and putting something in there with the greater than. The greater than both creates the file, it pipes it into a file. So now if I look, there's the file, and if I do a cat on file.text, it says hello there. If I want to create a variable and fill it, this is an environmental variable. I can do host equals, and there's actually a newer way to do this. I'll do the new way. So host name would give me the host name that I'm on. I'm putting this in a variable. So all I'm doing is the host name and putting in the variable. I can check with echo and see that it's in there. Now I'm going to do an echo and I'm going to use two greater thans and put it in. One greater than would overwrite that file. Two greater than appends to that file. So now if I cat file.txt, it put in there hello there, and then from ICR-Helios. So we're redirecting the output of the echo and putting it in a file. If we just did it with, again, without the second greater than, it would overwrite that, just to show you. So the other thing we can do is direct things using a pipe. If you're directing things from or to a file, you use the greater than or double greater thans. To direct to another command, you use a pipe. So if we do our grep time so again, that's going to give us this. Now I want to build on that and pipe it to word count minus L to ask how many lines is that? And it says there's 24. I'm not going to count them. I'll trust it. So redirecting output can be done using a pipe command. And you can use multiple pipe commands. If we wanted to pipe this into a grep, minus V means instead of keeping the ones with something, we're going to omit the ones. So let's say I wanted to omit the ones with use. So that cuts our list down, and then you can pipe that into word count minus L. So we have uh, three commands in there that we're piping between the first grep to the second grep to the word count. And now we're down to 18 lines getting through. So that's the power of linking things together with pipes. Okay, let's get to some writing of scripts. So this is an example on the left of a bash script that I wrote up, and we're going to go through some of these things. When you write a bash script, the first thing you want is what's called a shebang line. The pound exclamation point is called a shebang, and then you're identifying the type of shell that you're running this in. In Linux, it's common to do things in bash. So the path to the bash executable is /bin/bash. You can certainly do things in other shells like CSH is the C shell, SH is the Bourne shell, but it's most common to do things in bash, and that's what we'll be teaching here. So other lines in my bash script here that start with a pound sign are comments. And that's why I'm putting this in as a comment, and I put this in saying that pound anything means a comment. And you can even put comments after the actual commands. So any shell script, you're going to need to make executable before you can run it. I'm just going to list this one. I've already made this executable, so it's a little hard to tell here, but the green one there is an X. So from me being the user, that means it's executable. I also colorized it green with my LL script because it's executable. This is what it would have looked like without that. You can see there's no executable there. If I try to run it, it says permission denied. So if I make it executable, then I can run it and it'll not give me that error. It'll do lots of things that we'll go over in a minute. So every shell script needs to be executable before you can run it. The reason I put a dot in front when I ran it is to tell uh, Linux that I'm running something from the current directory. Dot dot, when we are using CD, means go back one directory. Dot means this current directory. So dot/script.sh would run script.sh from the current directory. So I already gave an example of setting an environmental variable or a variable, excuse me, by just using the equal sign. So if I set variable to sb.hello, then I can do word count minus L dot var, and that should count the lines in sb.hello, which it did, the same way as if we did like a cat sb.hello. We could either do a wcl sb.hello, we could do a cat of sb.hello and pipe it to word count minus L. So there's a lot of ways to do the same thing to count that there are 13 lines there. So loops, so that covers variables. Loops can be done in different ways. And I'll give you a couple resources for this as well. Basically, the normal way to do it is with a for and then your variable in and then a list. You can either have a list generated from here, you're doing it with an ls of star.fastq. This would return anything in the current directory that starts with anything but has a .fastq end. That's a genetic code file. So you could also put things like for file in A, B, or C, and then it would operate on those. Let me just show you some examples of these. Okay, so this is a good source for bash scripting for loop from Geeks for Geeks. So here it shows a list of 3 letters, A, B, and C. So the first time through, it's going to assign A to N and then echo out that variable. And $N is going to contain A. So you can see down here are the results. The second time through the loop, it's going to assign B to the variable N and then echo it out. The third time it'll echo C out. There are different ways of constructing loops, though. You can do it with a series, a numerical series in curly brackets.
Yes, there is a concept.
Then everything in the curly bracket, this is going to be from 1 to 5. So it's going to echo out the numbers 1 to 5, which again you see down here. But we can also add a step of 2 in there. So this is going to do the loop from 1 to 5, step 2. So it's going to do 1, then 3, then 5. And you can see that's what gets dumped out here. And that one we're going to skip. This is a C style. It's like the C programming language. So for I equals 1 is the starting condition until I is less than or equal to $N, which is assigned to 7. So it's going to continue doing this until I is less than or equal to 7. And then I++ is incrementing I each step. So what this does is it starts with I equals 1 and echoes that out, as you can see down here. Then it increments I by 1 and checks to see if this condition is still true. I is now 2, which is still less than or equal to 7, so it echoes 2 out, and so forth. When it hits 7, 7 is still less than or equal to 7, so it echoes that out. It increments it at 8. Now when it checks, 8 is not less than or equal to, so the loop is done. So this is a C-style loop. All these work fine in Bash. So you can use lists, you can use numerical versions, or you can use C-style or a variety of other things. You can also do conditionals in your loops. There are a lot of conditionals that I'll show you in a minute, but just some examples of a loop. Again, if we have number as our variable to come into the conditional, if $num equals 1, then we're going to echo it was 1. Elif is short for else if. So we're going to do an else and then another conditional. Elif $num is not equal to 0, then we're going to echo it out. Otherwise, it was equal to 0. So you can do multiple levels of conditionals in this way. And then phi is the opposite of if, and that's how it's terminated in Bash. For numbers, you can use things like -EQ for equals NE for not equals, LT is less than, LE is less than or equal to. String comparisons are more like minus Z for empty, minus N for not empty, and then double equals or not equals, for example. And you can also test for files existing or directories with a minus D existing. So let me show you some of the tests that you can do. This is in GNU.org and it's bash features. So I'm clicking on bash conditional expressions, and this gives all the different ones that you could want. So minus A is true if the file that you list here exists. And you can test for different kinds of files, like if it's a directory is the one that I showed. If it's a file exists and it's a regular file, things like that. But then these are the string tests. String 1 equals string 2. All sorts of expressions that you can use there. Let's look at our script again. So the script I'm showing here starts by doing the host name and executing that and assigning it to a variable host. I use capital letters. It's semi-common to use capitals for variables, but you don't have to. Then I use kind of an unconventional command, getconf, with this macro. I had to look this up, but this tells how many processing cores are on this computer. And we're going to run this on the head node and find out. And it assigns it to the variable n cores. Then we're going to print out the host name is this and has this many cores. Now, when we echo that out, we have to use double quotes because we're trying to evaluate some variables. If we use single quotes, it would actually print out $n cores instead. It wouldn't evaluate variables that are inside single cores. Then I'm showing just a few examples here again of how to use loops for file in. I'm just doing an ls. So we're taking every file that's in here and echoing file blank is in this directory. So it should print out one file per line. And then I'm just doing this C style, which should print out 5 lines again, 1, 2, 3, 4, 5. And then it's going to look and say whether a file named myfile.txt is in my home directory. And I know there isn't one there, so it should say that it isn't. So I'm going to get out of here and do /bash example. And I'm going to run that. And I'm just going to use the mouse to scroll back up here. Okay, the first line that printed out was the host name is ICR Helios and has 8 cores. So it was able to determine using that command and the macro that there's 8 cores on this system. And then it goes through and does its ls and lists that each of those is in this directory, and there's a lot of them. Then again, the next for loop is the C style one that prints out the numbers 1 to 5. And then it says again that myfile.txt is not in /home/Dave Turner. So that kind of sums up a basic introduction of Linux and Bash shell scripting. This just kind of gets you started on these things. The Linux commands are the most common used. There's a lot of other commands that you'll run across as you work more with Linux. And certainly when you write scripts up, if you get to the point of writing scripts, a lot of times you can even submit job scripts to Beocat or Beoshock to run fairly sophisticated things without having to deal with loops and conditionals. So if you didn't understand all that, don't worry too much about it. You can always uh, look back on some of these references and learn more, or ask us for help when you need to do something more sophisticated. But I would keep a copy of this quick reference. It is going to be available also along with this video on both the Beocat and Beoshock websites at the main level on the documentation. So you can always take the PDF and print out another copy as well. So I hope you found this useful, and thank you.